Every home has a breathing apparatus. The way that it's taking in air and breathing out air, even if you don't have a central duct system for conditioning, you still have things like exhaust ducts, hopefully. So let's talk about our central duct system. You need a way to get air to the equipment, which is called a return, and you need ways to get the conditioned air from the equipment into the rooms, which are called supplies. First thing to understand is that all this stuff needs to be designed in a computer normally, not necessarily just on a scratch of paper. Essentially, what you need to do is figure out exactly how many BTUs and CFM you need to deliver to each room in the house, which we have done. Then I had someone do the duct design for me and make a map of exactly how big each duct needed to be, exactly how long it should be, how many elbows it's going to be expected to take. Because of course, every little turn and downsizing I add to these ducts, if I'm trying to squeeze it through little spaces, it limits the airflow. And airflow is the whole thing in this case of a breathing apparatus for your house. So let's talk about the return for a moment. What you see over here is called a central return. It's just one duct that's going to take all of the air that the equipment needs in at one point. The other way to do this is to have multiple returns, maybe as many as one in each room. That is a nice way to do it, and it does solve some things, but it makes the system a little more complicated, and it also is not necessarily a better way to induce the invisible dynamics in your home to do what you want. This way, what we're doing is supplying to all the bedrooms so that all of the air flows in a specific direction, and we know how that works. All of the air is going to be returned from the entire house into this room, where it then is returned to the equipment for more conditioning. That's kind of a beautiful thing. So this central return has a 90-degree turn or two that it's taking before it gets to the equipment, and that's important because we don't want to hear the heat pump every time it turns on or turns off in the crawl space below us. All right, so coming down into the crawl space, one of the two crawl spaces we've got. First thing that I'd like to point out is my wheels. I'm very happy to have something that's going to save my back because this is a little lower than what the stool that I was using, which is just a mechanic stool. This is called the Aero Creeper, and it's actually made for airplane owners to be able to clean underneath their airplanes. It's got a tool tray and even a cup holder and a headrest, and so you can easily work overhead and not be straining your back and your neck. Back injuries are something that I've had repeatedly over the course of this build, and you can see that I'm like collecting my injuries as we go. First thing is setting your boots and setting your equipment when you're talking about an HVAC system. And we have two HVAC systems in this part of the house. We've got the heating and cooling system, and we've got the ventilation system. The sealing and insulating is important even if all of the ductwork is inside of the house, inside of the enclosure, the skin, because we are not designing this thing so that it can bleed air out or in through the crawl space where I know exactly how many BTUs and CFM I need down there. I don't need extra leakage contributing to that. The goal here is to get all of the air and the heat or the cooling delivered to the rooms where they're supposed to go based on that design that I already mentioned. I'm insulating these ducts because I don't want the outside of them to be wet when we're air conditioning. So the ventilation system does not need to be insulated past the ERV on this side of the house because all of the air inside of it will be roughly the same as the temperature inside this conditioned crawl space. This is not a vented crawl space. This is a mini basement. I wanted this space to be for services, and you'll see as we go through here, it's getting pretty crowded in here with just the things that we have here. Ductwork, plumbing, electrical lines, all the equipment, things like that. You can tell that this is a heating and cooling duct because it's insulated. And I put the register for this up by the ceiling so that I could take advantage of that Coanda effect and laminate the flow to the ceiling so that it'll travel further into the room and then start really mixing the air. Now, this duct is not insulated, though it is still sealed, and that's really important because ductwork is plumbing for air, so you always want to seal it. But the register for this is going to be a lot closer to a person's face because this is delivering fresh air. All we want to point out is that where you put these registers becomes important when you're trying to elegantly affect this. This is giving the air. Down here, we have a small stack that's going to be taking air from behind a toilet in that way that we already have discussed of removing the air so that it takes the odors out in exactly the direction that you want. There are two types of ductwork that I'd like to point out, and I used 99.5% rigid sheet metal. And I've got my Malco tools here that I'll show you what my favorite ones that I've been using a lot are. But this is very permanent, somewhat difficult to work with, very rigid, obviously, so it does not bend, and it takes a little bit more time to put together. And then also, I have to insulate it after the fact. This is a pre-insulated flexible duct. You might also hear it called flex duct. It is slightly less good at moving air around because it introduces more resistance, because it's got essentially on the inside of it this spiral plastic material, and you can see looking down into it that it's not perfectly smooth, not like this is, but the spiral duct, I keep getting this question from my HVAC mastermind students. They're like, so you're not using any flex at all? Because the idea for most professionals is that they use the flex duct when you've got a straight run. And it's not going to introduce that much resistance. It's got basically, it can do 90% of the job of the sheet metal. And so you just upsize it by 10% to make sure that you're not going to, it's just an easy way to fix for that. But having installed just this one, which was easy for me because it enabled me to get from this boot over here, which is going up into the entry. It's the heating and cooling system for the entry. And I needed to kind of go in this curvy line, which I cannot do with rigid duct. Was nice for the benefit, but even though this is as taut as it can be, and they say that you're supposed to stretch it out nice and taut, and then you hang it nicely with this stuff, it just does not feel permanent to me. Everything else on this house I'm building to be a 100-year house. This is the one thing that I'm like, number one, no way is this going to last for 20 years without deteriorating. And when it does deteriorate, this plastic, like, I just don't trust this stuff. I think that it's going to age, and it'll get brittle, and there will be holes in it. At which point, the next layer in line, which is this fiberglass insulation, will start to potentially slough off, and you can actually see it floating around in the air. I should be wearing a mask right now, but I'm really tired of wearing a mask on video, so I'm not going to do it right now. But this stuff will end up in my airstream now. And then I won't be able to see any of that because I've got this Mylar radiant barrier coating on the outside, which introduces a little bit more insulation power, although it's not reflected in the R value of this stuff. That's kind of how radiant barrier doesn't get counted into R value. Anyway, this is all, the one other benefit is that I don't have to insulate this because it's already insulated. So when you start to weigh those two things, the way most people use HVAC systems is they're gonna like rip this all out in 20 years anyway when they have to replace the system and replace their entire duct system. I don't know why that keeps happening, but a lot of houses that we go into as consultants and that my mastermind students go into, they say, oh yeah, I'm recommending total duct replacements because it's just like the first time they did it was not good. So I don't think we should be doing that. The rest of this system is going to be a 100-year system, and honestly, it won't need to be touched. We took apart some duct systems in Chicago that had been welded together. You can do that kind of a permanent install with the sheet metal. You just cannot do this with this flex. So even though it's nice and it saves some work, and I see the upshot of it and why it was invented and why it's used by professionals who are not me, I'm doing this for my own family, I don't think it's worth it. It's not a good trade-off, in my opinion. Does it make your job harder to use all sheet metal? Yes. Life is hard. It's hard to have good stuff. You have to work hard. I'm used to that. It's okay. So that's all I'll say about this stuff. With the sheet metal, mostly we're using round. Round is a little bit better at moving air than square is. But you can't help, if you're going to go up into the walls, you got to have rectangular duct. And so we're using 4-inch, 6-inch, and 8-inch going up into the wall cavities. And that means that it's like a 10-inch wide by the depth of the wall, or a 12-inch or a 14-inch. And this is a simple snap lock system. So you basically put the two together, you start at one end, make sure that you've got that handled, and then you kind of keep moving down this. These get sold in sections, it's that easy, sections that are 3 feet or 5 feet. I believe you can get them longer, but in the HVAC supply house that we're using, they just come in 3 foot or 5 foot sections. You will be cutting shorter sections like this because, of course, not everything in the house is going to be 3 feet or 5 feet increments. The tools that I have used a lot of, and as you saw in our tool video, all the Malco tools, I give you a tour of every single one that I got with the kit. But the things that you really, really are going to use a lot of if you do this kind of an install. Number one thing you're going to need is an electric drill to handle all kinds of different things, including this fitting that I'll explain in a minute, because you're going to need to put a lot of screws into this thing. So the screws that I was mostly familiar with before starting this project were these, which are also Malco screws. And they make 2 different kinds. This one's called drill bit tip. It ends up making a fair amount of small little shavings of metal, but I thought this was better because to have a drill bit on the tip of your screw is cool. Like, I think everybody can agree about that. But I also got 2 different kinds of zip-in screws. And they, as you can see, do not have a drill bit tip. They have a pointed tip, which I thought, no way that's going to work as well as the drill bit. But it actually does, and it literally does zip right in. These are hex head, and they have a slotted, if you need to use a screwdriver at some point down the line to take them out, which it's not really a professional tool, screwdriver, but you can do that, or if you needed to have a homeowner be able to make some corrections. The little guy is a 3/8, and the big one is a 3/4 inch screw. I'm using the 3/8 mostly for the ducts themselves, and then I'm using the 3/4 inch sometimes for like heavy portions of ductwork where you're trying to sandwich together a lot of different pieces of metal that it's hard to get this thing through because you need it to really bite into every single layer. So that's what these are good for, but these are also really good for screwing into wood. So when I've got strapping that I'm using to suspend the ductwork, I'm just putting one of these big 3/4 inch guys right through there, and I don't have to change the bit on my drill at all, which is nice. It's like literally just the little things that save you a minute here and there become really useful. Because in general, ductwork is not that fun. I thought that this was going to be a real joy to be done here. I will say that the plumbing system, the water lines, which I also ran, that was actually like kind of fun. It was like do. Ductwork, not fun. So pay your HVAC professional as well and appreciate them. Other things on the electric drill side, aside from just driving screws, are number one, the circular hole saw, which I used a ton. This is a really important tool because if you're going to be going into ductwork and trying to make collars and saddles and things like that, doing it by hand, like scribing the hole first and then drilling into it and then using some shears to go around in a circle, it's just not that much fun. This thing is really, really fast. You got to point it in the direction that you're going, by the way. That's one thing that I figured out. I was kind of going flat in, and I'd go around in a flat circle. As you can see, this little drill bit spins around the hole. But you got to angle it into it so you're cutting in line, and that actually goes a lot faster. Also pretty important is this awesome shear set that makes both sides reusable. So basically shears off a little strip. You end up with a perfectly little ribbon of deadly sharp steel that you do not want to touch with your bare fingers. And I used this a ton because also going around, especially working with like when I've got the boots sticking down into space, and then I have to make cuts to make them shorter, like they were this long at first, and I just wanted to put them in place and then figure out where the equipment was and figure out how all this stuff was going to work. Then I need to cut them back. Doing this while I'm down here, or I can imagine up in an attic, it's just a lot easier than trying to work by hand. So the manual tools are also useful, and you don't want to be caught without them for sure. I would say number one, you gotta have shears. I tend to like the green ones, which I think are called lefties, more than the reds, but these are the bulldog snips, which are for really short. You'd see that the size of the cut that they make is much, much smaller than the big guys. But where these are for cutting through a single ply of metal, you're going to have all kinds of little folded areas like where everything comes together and you've fastened it already, and then you're going to need to cut through that, and you're just not going to be able to do that with anything except something like this. Crimpers, really useful and very important, because every single cut you make, where you make something like this, now I have a straight end on both of this, and that means that I have to have a crimped end on both sides, which doesn't make sense because generally you're going to crimp one side, then the next piece you're going to crimp that side, then the next piece you're going to crimp that side, so that the air is always going in. It's kind of like flashing on the outside. But these things, super easy to use. I always go full depth. There are a couple different sizes of this, but I find that like the further I can stick this thing into the next duct and then screw it together, the easier it is. And you'll see that machined ones are going to be like rib the whole way down. In general, in real life, you don't need to do every single one. You can do it a couple inches apart like this, and it'll still be small enough to fit inside an end that's uncrimped like this one is. I have the two sets of these. I've got the 6-inch size and the 3-inch size of the flatteners. It's called a handbrake. And honestly, I use this all the time because there's always like little things that are bent up on the lip of something and you're trying to fit them together, and you're just going to need a little set like this to be able to stick in even just the edge there. I might not use the full breadth of the plane. Honestly, these, super low tech, but I use these a ton. They're covered with mastic right now. And you just basically temporarily put this stuff in place so that I can hang a duct without having an assistant hold it up or having to really eyeball exactly how long all of the strapping needs to be. And then once I'm done with that, I put this end of the duct up in there, and then I fasten the other end in place. Then I can come along and measure exactly how much strap I need so that I'm not wasting a bunch of strapping. And this thing, I was kind of amazed at how helpful it was. And then the two last things are obviously your big shears, which are straight snips for making straight cuts. Like, again, you don't want to get caught without these, even though you have a really awesome tool like the drill attachment set of shears. And then also, obviously, your ruler / level / square. That also has a scribing tool in it. I use this a ton as well. And being able to scribe instead of whipping out my Sharpie, it's got a big fat edge on it, is just really helpful. So all in all, I've used the word helpful like a million times, but I gotta say, I've done a lot of hack work in my life because I've not always been, this is obviously the first house I've ever built. For real, we built the tiny lab. But I used to run a training center and I had to build props and things like that. And like, I don't know any of this stuff. So I've used not the right tool about 1 billion times. And now that I have the right tool, it just makes everything a lot easier. So you want to make sure that if you are going to do something like this, that you have the stuff that's going to make your life a lot simpler. So let me move you back into the space and I'll show you a little bit more about how this duct system is coming together. So you can see here where we've got a really excellent use of flex duct in conjunction with rigid duct. This all will be insulated, and I will have to come along and inspect this, but this is not the same very flimsy plastic material. This is a more durable type of flex duct, and so I needed to be able to connect these two things that are not really in line with each other. They're just a little bit off, and it makes your life that insane that you would literally spend hours trying to figure out how to connect these two things if you were using a rigid material. So being able to use the flex duct in this case just saves a lot of time, and it makes it's like, it doesn't matter that it's just a couple inches off or that it's at the wrong angle. So you can see here that this is not sealed. Do not ever think that ductwork, just because it snaps together and it sounds like it has a good lock on it that's airtight, that it's airtight at all. This all needs to be masticed so that it starts to look like this box and the rest of this main trunk line to the heating and cooling system. You can see that we've sealed up every one of the seams between pieces of ductwork, every one of the turning points on an elbow, and these little seams on the elbows as well, and every one of the fasteners too. So right now, I have been through about 7 gallons of mastic on this house, and I am not done yet. I think I might need another gallon. This box, by the way, I was pretty proud. We built this. I showed a little bit of that in a past video, but what I needed to do was, they don't make plenums that are universal sizes. For some reason, all the manufacturers just make ones that are for their specific brand. And so you just gotta buy one that's like in the range. I needed a 2 foot by 2 foot by 2 foot cube to be able to put a 2 by 2 filter that's a 2-inch deep filter on. And of course, getting that 2-inch deep filter, like all the things that we're doing on this house are pretty much non-standard for the entire HVAC industry. So I bought the plenum kit, took it apart, did not use any of the folds or locks that they had built into it, cut all those away or bent them out, and then assembled them into a new shape that ended up having to be a box that has a rectangle box that goes down through the floor on one side of it. And then make sure that that's all tight and sealed up. And as you can see, this thing is not going anywhere. I'm really proud of it, actually. By the way, you want to make sure to calculate always how big all of these openings need to be to each other. So it's 16-inch round. I know how many square inches of opening that is. And then I found out how much of a rectangle I need if I'm trying to fit down between these two floor joists, which is 14.5 inches wide. What is the length of that I need in order to make sure that I'm not restricting, that this is not bigger than what it's coming through first. And so on the other side of this, we've got 2 rounds, one 8-inch and one 10-inch round. Each of those are for the pieces of equipment that are supplemental to the heating and cooling equipment, which is our Mitsubishi PV series heat pump over here. We have the HEPA filtration unit from Fantech, and we've got the ultra-aire dehumidifier, and that's a 105. You can make almost any of the fittings that they would make in a factory, but you gotta decide whether it's worth it for you or not. So as far as caps go, you can buy something that's nice and flat and round like this. Honestly, this is only 2 pieces of sheet metal, and they're not airtight. So I would still have to mastic this. Or I could just take a piece of sheet metal that's cut in a circle and then trim the edges into a flower shape and then bend each of those over and then mastic the whole thing. It takes a little more on the mastic side and a little more on the screw side and a little bit more on the time side, but is it worth it to you to go out and have to buy an extra cap that you forgot about? Because of course your design is not going to be perfect. You're going to have to make some stuff up in the field, even in a nice wide open crawl space like this one is, because clearly plumbing, drain lines, all kinds of the other things that are already down here that I have to work around. So this return plenum is what feeds everything inside of this equipment shed. And let me take you in here and show you a little bit more about where the equipment is laid out. Here we have the workspace where we're going to do the work. And Brian Orr from the HVAC School podcast, who also runs Kalos Services, they do all kinds of different stuff, actually helped us start Home Diagnosis, the television series. So I'm grateful to him for that. But he's going to come down and commission this with his team. So what I have left to do is put the line set, which is going to be a Mueller Streamline, 100-foot long line set that's going to go over to the other side of the corner of the house there. 100 feet, and it's going to be pretty awesomely insulated. I'll show you all about that later. So that needs to go in, and the electrical needs to go in, which is right up here, this box. But essentially, the rest of this is already all ducted up. So we've got the return coming in, the machine we've already tested for airtightness, which I was very happy with, and then we've got the supply plenum, and you can see this is coming in right here. This is super important, and I'm going to hit on this again later when we talk specifically about this dehumidifier. But the ultra-aire dehumidifier that's here, that's a whole home dehumidifier, which, by the way, we're building houses more airtight than we ever have before. Your HVAC system is smaller than it's ever been before in new homes. Therefore, it's going to dehumidify less. And it's going to run less in general because we've lowered the load by air sealing and insulating the homes, as we already mentioned. You need to have a dedicated dehumidification solution in basically every new home, is what a lot of people, including me, are agreeing on. So this thing is hooked into the return box, the filter box that I've got. It also has a MERV 13 filter built into it, which is great. That's going to filter out a lot of the particles. We have here a cool feature that I can open up to return some air from the crawl space. That obviously will go through the MERV 13 filter as well. I would never open this thing the entire way, but if I wanted to slightly depressurize this crawl space and get some air from here circulating around the house, and I already have a supply dedicated down here from the heating and cooling system. So if we wanted to introduce more or less circulation for the crawl space itself, we have the ability to do that with this. Normally in an ultra-aire system, this is for introducing outdoor air and then dehumidifying it immediately before you distribute fresh air throughout the house. That's called supply-only ventilation. That'll slightly pressurize the house. That's fine. In this case, I would use it to introduce some very refined intentional pressure imbalances within my house, which is a useful thing to do, and you can see more videos about that on our channel. So here is the out. This is the dry air coming out, and it goes into the supply plenum, not into the return. This is a really big deal, apparently. I was not on the train of thinking that there was any good way to do this in particular that everyone agreed on, but it turns out that everybody is wrong in the last 20 years, and that we've been plugging the dry side, the out of a dehumidifier, into the return, and then putting dry air through our equipment. That, number one, it's hot air, and so it's going to make things a little bit weirder inside as far as mechanics of this, but it's also going to not allow the heat pump to do any dehumidification at all, because it's basically drying out any of that stuff. So you're not going to have the condensate coming out of this, apparently, which is part of the way that it's designed to work, and so it just kind of shoots the efficiency of this entire system in the foot if you dump this into the return side. So everybody right now is trying to get people to dump the dehumidifier output into their supply plenum so that it bypasses the equipment entirely, and that's what we've done here. Into the other side of this is being dumped the HEPA filtered air. That's 240 CFM that kicks on every time this kicks on as well. We could run that nonstop if we find out that we have an issue with particle buildup or VOCs in the house. That's got a bunch of different things going on, and we're going to get more into that in the ventilation side of things. But it does hook into the duct system, so I wanted to make a note of that. By the way, one thing I wanted to just point out is here, you can see we've got, that's the sound of our other dehumidifier kicking on. We've got flex duct on both sides of this, and we've got this cool little hang kit. This hang kit is from ultra-aire, which is owned by Santa Fe. And so that you can get it for either Santa Fe or ultra-aire systems. But it's nice that it's like not rigid. So when this piece of equipment does kick on, like what you just heard upstairs, maybe you can't hear that, maybe I'm just super sensitive to it, it will hum a little bit because it's got a compressor built into it. And so this decouples that vibration from the structure of the house, which I'm hanging it from. And then these bits of supply and return flex duct, just like a foot of it on each side, decouples it from the duct system, which obviously is rigid, which means it's going to carry vibrations around. So as much as possible with every single piece of equipment in this house, we've added at least a foot of flex duct before and after the piece of equipment so that it doesn't vibrate into the duct system. The things that are inside of the house that are going to interfere with the airflow and the flow of heat or cooling around the house are both the doors of the rooms themselves and the doors in the ductwork. We have a couple different types of this, and I'd like to show you. One type of damper that we'd put, which is a doorway for ductwork, is called a butterfly damper. This is basically going to keep the air flowing in one direction only, and if it tries to flow the other direction, it'll stop it. That can be very useful because in some cases, we're plugging in multiple pieces of equipment to the same duct system. That's an efficient way to use the fact that you've got a breathing apparatus in your house. Use it for multiple things. This is going to keep that from being a two-way street. It becomes just a one-way street. Another kind of damper is like this. It's just a flat piece of metal in the middle of a duct, and it can twist closed. Now, if this would have a handle on it, it would be a manual damper. And I would set that one time, and I'd forget about it after measuring it. This one happens to be run by a motor on top. That's a mechanical damper. And this one can open or close based on certain factors that I program into the control system on the house. That sounds really complicated, but it's pretty easy to do. So we've got multiple examples of each of these kinds of dampers, the doorways, inside of our duct system to make sure that we're delivering exactly the right airflow, velocity, BTUs into each of the rooms. Now, toward the center of the house, this is where the heating and cooling supply, the ventilation supply, that's the fresh air, and the ventilation exhaust, where all the stale air comes down from the second floor, all shoot up there through this 2-floor high chase, this mechanical cavity in the middle of the building. You can see that things are getting a little tight, like they're all kind of close together. We also have the plumbing in here, we've got the drain lines, we've got the vacuum tubes, and you can see that my supply comes down and shoots this way. My exhaust comes down and shoots this way, even though, really, that's not the way that I want it to shoot. I want that to shoot that way too, because the line that I'm trying to connect to is back in there. But the fact is that you have to work within 3D space, and you can't always in a duct system, and you'll see this reflected in the duct design that we had. On a piece of paper, if you were going to try and have ducts and ducts and ducts all in one line where you're looking at a bird's eye view and you can only see one duct because they're all hidden behind it, it's just not going to work, because I actually do need to get in here as a human being and work on some of this stuff at some point. And so you can't really layer things. So I'm going to have to take this the opposite direction that it needs to go so that I can get past some stuff and then shoot back to the damper where it actually belongs. And again, I'm having to make sure that this stuff is out of the way so that I've got enough clearance everywhere. So this, thinking about space is something that the HVAC profession is big on. You have to be pretty good at trying to fit this stuff into spaces. And one of the main problems with the difference between a duct design and when you show up on site and start installing them is that sometimes they're not going to give you, like, what if this crawl space was 3 feet high and not 4 feet high? And the HVAC guy showed up on site and said, well, all my design was based on the fact that I would have a certain amount of space, and now you gave me a foot less space. Or I thought I was going to have this closet, but oh, the homeowner wanted that closet for their kids' clothes. Sorry, you got to find someplace else to put your stuff. Happens all the time. So if you want good HVAC, you want it to work well, you have to make sure that it's clear to everybody on the team that the HVAC is really important and that we need to make sure to respect the planning process of that and then the actual execution and giving it enough space. Because not only do I need the room for this 6-inch duct, I also need the room to be able to work around it and connect this piece here to it, which means I need to be able to move this, rock this back and forth before I had installed it. And of course, the way that I'm doing this now is you got to think ahead about these things. You connect this to that, and then I'm going to slide this up into it. But I've been caught plenty of times now on this install where I'm connecting things, and then the one piece that's in the middle, I can't move either side, so now I have to figure out, how am I going to do this? Flex duct is one of the ways that you can figure that out, by the way. But here we've got what's called a saddle. It's a takeoff, but let me show you a couple different versions of takeoff. So this is a takeoff for a 4-inch duct. But as you can see, the surface here that's got this sticky gasket on it is flat. So it's made for me to put this round duct onto a flat rectangular duct. That's not really going to help me because, as you can see, I'm using almost entirely round ducts. So the next thing you would move up to is a saddle, which is a takeoff that is rounded. So it can be put onto this kind of ductwork. And so I would make my hole with my drill mount hole cutter, and then I put this on there. Now this is made out of a bunch of different pieces of metal, so I'm going to need to seal it just like you can see all these things are sealed with plenty of mastic. But that's not all. You're going to want to have inside of this another very important piece of equipment. It's called a damper. Does not cost a lot of money. Please do ask for dampers to be put in on every single takeoff of a duct. Worst case scenario, you don't need them at all because the duct balancing is perfect with you just following the design, in which case all these dampers would remain wide open. But if you ever need to adjust them down or close them off, you have the option. Now, you can have the damper actually built into the collar, and that's the second level. To do this, I actually just bought the damper separately with the collar, the takeoff, and you can actually, they make little holes for you to put a damper into. So that makes it very, very simple. This one, though, has another feature, aside from the fact that they saved you the time of putting the damper in place, and that's called a scoop. So the scoop is made so that if I've got a duct where I've got air moving down this way, I put it in this direction and it will actually catch the air and encourage it to make this 90-degree turn and come this way instead. If I didn't have that scoop in there, what are the chances that air that's moving in this direction is going to want to take a 90-degree turn in the middle of what it's doing. Probably not a lot. So you can use a 45-degree takeoff, in which case you have to be thinking about space again, because making a ductwork that does a 45-degree branch and then has the time to go somewhere else also takes time. So if you've got a wide open attic, you've got a wide open crawl space, that can be done. You need to think ahead about that stuff. Or you can use scoops. Now, in the return side of the ventilation system, you don't need scoops, because the system is sucking stale air out of all of our bathrooms and out of things like our litter box, our cabinets, our laundry room. And you don't need to incentivize the air to go in a certain direction, because sucking is a lot easier on airflow than blowing. One thing about these dampers, by the way, when you're fastening the ducts together right near a damper, you need to just test to make sure that you can still run the damper all the way open and closed, because sometimes you screw a little too close to it and then you can't open or close the damper. It's important also to talk about the doors that are at the ends of your duct system. At the ends of the octopus tentacles are what's called grills and registers, or what's called terminations if you're in the HVAC industry. I am going to put a grill on my return. A grill doesn't have something that you can open and close, which is like a damper. A register will, and those are mostly on supply. On the return, you don't want anybody to be able to restrict the airflow, and in fact, it's really dangerous in general to put one of these low on the ground, because it's possible that somebody might, not thinking, put a little end table up against this, or put a couch, God forbid, up against it, or put their trash can against the return. Like, be very cognizant of the fact that all of the air in the entire house is going to get distributed from this hole. This is going to everything in the house. And obviously I need to cover it by not putting a couch in front of it. I want something nice, because I don't want my baby to be stumbling into my heat pump, or into my dehumidifier, or into my HEPA filtration unit. This is kind of like a Willy Wonka scenario. So I could get the easiest, cheapest thing, which is, you've all seen it, white, metal, fins, boring, not that pretty. Or you could do this. This is one of many designs. I like this one for very particular reasons, from a company called Stellar Engraving. The reason that I like this so much is I've tested it. I test all of their grills to make sure that their designs, while they can be very pretty, do not also have the unwanted effect of slowing down the airflow or introducing what's called too high of a pressure drop. So a lot of wood registers, especially on supplies that you'd put on a nice wood floor, not a good idea, because they introduce a lot of back pressure, a lot of pressure drop on it. And you do not want that. In general, you want the airflow to come out. That's the most important thing. For it to look nice, it's nice. But this has both the looks and also the airflow characteristics that I want. What's going to go right behind this Stellar Engraving CNC carved slot cover is the filter, because this filter box is going to all my machinery, and it's going to have the MERV 13 filter that I want in place. This is going to be a 2-inch deep filter. And I can, if I want to, because I've got 3 machines, remember, pulling from this one 2x2 box, I can upsize this filter to a 4-inch deep filter. And what happens when you make something, you go from a 1-inch typical to a 2-inch to then a 4-inch, is I'm taking the zigzags that go down through it, that's the filter media, and I'm making them much, much bigger, so that the surface area of what is allowed to filter the air becomes much bigger. The filter drop across the 2-inch MERV 13 filter is going to be something on the order of 0.2 inches of water column. That's a little high for a filter, but it's probably fine for me to deal with, because number one, both of these machines have their own built-in fan, and that machine right there, the Mitsubishi, can deal with up to 0.8 inches of water column for total external static pressure. So that's all reasonable. If I wanted to take it down to a 0.12, then I could replace it with a 4-inch, and I may do that. You'll see a video coming out about that if we decide to do that. And that would mean just detaching this flange. Since I made this box, it's very easy for me to modify it, and then moving it 2 inches back and reattaching it. Now I've got room for a 4-inch. So this, I'm very proud that I'm going to be able to draw people's attention to the breathe in piece of my conditioning equipment. As far as the breathing out part, the registers that you're going to be installing, I don't want to get too crazy with it. I do not want floor registers in general in this house because I don't like the idea of dust falling down. Like gravity pulls things down. So if you have floor registers, dirt is going to get in there and it's going to fall down, and then it's going to color your air, whatever that means to you. You can smell it, it's going to have particles in the air, etc. It's just going to be dirtier. You might need to clean the duct system more often. I do not intend ever to have to clean this duct system because it's made out of the right materials. It's not going to deteriorate, it's sealed tight, and I'm going to keep the house in general very clean. We've got this filtration, everything should be fine. So I shouldn't have a major dust problem. Remember, if you do have a dust problem, don't solve it immediately with filtration. You should get a blower door test and get some infrared imaging and find out why you have dust in your house, because it's not normal to have a bunch of dust all over your house all the time. So the register has two things in the case of the ones that we're going to be using. It's got these fins that are kind of vertical, and I can change the direction of these fins so that when the air comes out of this, I can make it tend toward one or the other direction. They make ones that have bi-direction. I can't remember what they call all this stuff, but it's not that important. And then the secondary control here is this damper that is operable with this little handle here. These don't do as much as you think, generally. I've tested them in the field, and like, if you were to close this off totally, it looks like it's going to be zero air coming out of here. Might still be a considerable amount of air coming through, depending, again, on the type. But you don't want, in general, to be messing around with this too much. What the HVAC professional is going to do when they set up the system, and I'm going to be doing this myself with the assistance of Brian Orr from HVAC School Podcast and his Kalos services team, is to run the system with all the dampers, the manual dampers at all of the branches where they come off the trunk, and all of these wide open, and just see if the duct design was so perfect that all of the duct distribution of air and BTUs is perfect without us doing anything to it, which can happen. And then, at that point, if I need to adjust things, I'll adjust the manual dampers down in the crawl space first. And then, if I need to fine-tune anything, I'll do this. But when I start closing this off, and like, let's just say that you have a bathroom that always is cold in the summertime, and you've got somebody who closes that completely in the summer because I just don't want my bathroom to be that air conditioned. Crazy. Number one, that's a sign that there was not a duct design done on that house. That's a clue. Secondly, this is going to do two things. It's going to, yes, slow down or prohibit airflow out through this, but also it's going to introduce back pressure upstream. So it's going to make everything up to the air handler potentially also work harder because it's going to start squeezing and basically increasing your blood pressure, if you think of your house as a body again. So I don't want this to be happening a lot in the house, and I would never want to buy an app and a bunch of smart devices that let me control the registers in my house from my phone, because just going around and controlling your registers willy-nilly, like, first of all, you can do this right from the get-go and you should never have to even touch these. Secondly, you can't be deciding that I'm going to turn off the conditioning to this room or that room, because you're going to, the whole system is going to start crashing down. The home is a system. Your HVAC system is a system. There are no products involved in this conversation. It's all components that need to be assembled into the right configuration based on a computerized design. It's all very smart. Please don't get in the middle of it and start messing around with an app on your phone closing off dampers. But that said, these are the last doors in line that are going to have a major bearing on how your system works. Right now, budget-wise, we're at about probably $3,500 to $4,000 on the ductwork side. And that's with 4 independent duct systems. Heating and cooling in the main house, ERV system in the main house. We also have the makeup air system, which I'm going to get to in the ventilation video. That's for our kitchen exhaust. And then we've got 2 independent duct systems over in the studio side. We've got the HEPA loop, that's the filtration loop, and then we've got the ERV system over there. $3,500 is just the cost of the duct work itself, not the cost of any of the machines that hook up to it. It's all rigid. I'm using a ton of mastic, as you already said. I've got the tools and the screws and all the stuff that goes into it, and then also the time. And this has taken me, I thought maybe this was going to be a quick job. Not going to be a quick job. I was advised that even with 2 guys who work all the time on this kind of stuff, 5 days solid is what it would take. And I've been down here for months. Part of it is that I'm the builder and the general contractor, so I'm like skipping upstairs to do some insulation work or whatever needs to happen with my crew, which is my parents, as you know. And so I've not been full-time down here, but I've been working on this for probably 6 weeks now. But I'll say that in the end analysis, even before I've turned any of the stuff on and see how it works, it's worth it. Because lots of other stuff on this build has taken a ton of time, like putting in blocks in wall cavities. So much time. You know, doing the air tightness measures, doing the sheathing, making sure that the nail patterns are all in the right place, making sure that we have everything hung properly, making sure that everything is square and level. It's all hard. Building a house is hard. There is nothing about it that's easy. So don't think, oh, because it's hard, I don't think I should do it. Everything that's worth having is difficult to do. And so I hope that you take what I've shown you in this video and think like, oh, cool, it's doable. Here's how we do that kind of stuff. And not like, oh my God, I'm never gonna do that. That's crazy. Because I already feel like it's worth it and I haven't even turned on the system yet. So stay tuned because we're gonna have, when Brian comes down with his team, we're gonna do the commissioning on the system and actually test how many BTUs are being delivered through the system and also out of each one of the registers. That's gonna be really exciting. We're gonna set up the mini split that's gonna be in the studio. All kinds of cool stuff coming on the ventilation side as well. Please do comment if you have other things to add about ductwork. Like and subscribe. Tune in next time.